Okay, on our last example, we have an equation that kind of contains some funky rational exponents, such that we've got this to the 2/3 power. If you recall from section R.3, where we looked at rational exponents, if you have something along the lines that are, like y to the 2/3 power, that is the same thing as the cube root of, see where the cube root came from is the denominator, the cube root of y squared. Or you could say it's the cube root of y, all of that squared. It doesn't matter where the power goes. So remember, these rational exponents are actually radicals, okay? I could write the square root of 9, if I wanted to, as 9 to the 1/2 power. The index on a square root is understood to be 2. Now it is in rational exponent form. All right, so here on number 72, we essentially do still have an equation with a radical in it, okay, with that 2/3 power. We're going to isolate that thing first by dividing both sides by 3. So we actually need to solve quantity x minus 6 to the 2/3 power equals 48 divided by 3 is 16. Now my whole goal is to get in there and solve for x. So I need to get the raising to the 2/3 power off of there. Now think, what's going to get that done? What power is going to get rid of the 2/3? Here's what you do. You raise both sides of your equation to the reciprocal of the power. 3/2 to the 3/2 power is what you're going to do. Okay? Now let's talk about why that works. Over on the left-hand side, you have the quantity x minus 6. Now, remember, when you have a power raised to a power, the rule is you multiply those exponents together. Okay? Recall when you had x squared to the 3rd power, that is x to the 2 times 3, x to the 6th. That's what I'm gonna do over here, but I'm just multiplying some fractions together. So 2/3 times 3/2 gives us 6/6. Multiply across the top, multiply across the bottom. Hey, and y'all, 6/6, that's just 1. So I really have x minus 6 to, whoa, back up. I have x minus 6 to the 1st. That's just x minus 6, right? Okay? Now, if you would have a problem that said something like, I don't know, I'm going to make something up, x plus 4 to the 3/4 power equals some number. I'm just going to say k as in general. What you would do there is you would raise both sides to the 4/3. Always do the reciprocal of the power, okay? And that just leaves you with x plus 4. Now, you'd have to figure out what k to the 4/3 is. We don't know that. Over here, we're going to have to visit about what is 16 to the 3/2. Okay? Now, remember, these fractional exponents are of the form power over root. So another way to write 16 to the 3/2 is you can say it's the square root of 16 cubed, right? The power is 2, the root is 2, that's why I wrote square root. The power is 3. Another thing that you could do is you could say it's the square root of 16 and put the power of 3 outside. I'd rather figure out what that is instead of what's the square root of 16 cubed. 16 cubed is ugly. No, thank you. Okay? What I'm going to do is say the square root of 16 is 4, right? Now we're looking at 4 cubed. 4 cubed is 4 times 4 times 4, 64. So I have x minus 6 equals 64. add 6 to both sides, and I get x equals 70. Maybe. Why am I saying maybe? Because up here in orange, I use my power property, and you know, anytime you use your power property, you have to check answers. Okay? So I'm going to come over here, and I'm going to check my potential solution of 70 by putting it in for x. So I'll have 3 times 70 minus 6. Let me go ahead and do that. That is 64 to the 2/3 equals 48. Okay? Bring down the 3 times. Now, 64 to the 2/3. This time the power is 2 and the root is 3. So this is the same thing as the cube root of 64 squared. Okay? So that's how we do to the 2/3 power. So here I'm going to have 3 times the cube root of 64 is the number we cubed to give us 64. The cube root of 64 is 4. 4 squared is 16, and when I multiply that by the 3 out front, I do get 48. Yay, so that's an actual solution, not a poser, not an extraneous solution. So my solution set is 70. Hooray! Now let's fill in the blank for our concept connections, and we'll call it a day. This says, number 1, blank value equation is an equation of the form absolute value of u equals k. So I think we'd probably call those an absolute value equation. It says if k represents a positive number, then the solution set, remember what you do? Is you break it apart and you say it's u is equal to k or u is equal to negative k. And so I think what they're going to say is it's going to be k and negative k. Now sometimes you have to do some algebra because that u represents an algebraic quantity like in our examples. All right, it says if u and w represent real valued expressions, and that just means algebra expressions with no imaginary terms in it, real valued expressions, then the equation absolute value of u equals absolute value of w can be written in an equivalent form without absolute value bars as, remember what you do? You say u equals w, or u is equal to the opposite of w. That's actually what goes in the blank right there. I'll just leave it down below. All right, 1.6 is done. So go ahead and start that homework.